Hello everyone, welcome back to my channel. I hope you are doing well. If you are new to this channel, please subscribe and press the notification bell so you never miss our latest video on metallurgy, material science, welding, heat treatments and mechanical engineering. Today's topic is how to identify ferrite and pearlite microstructure under an optical microscope. By the end of this lesson, you will understand what ferrite is, what pearlite is, and how ferrite and pearlite are formed, how to identify them under a microscope, why they are important in steels, common mistakes students make during identification. Steel is one of the most widely used engineering materials in the world. Its mechanical properties depend largely on its microstructure. The two most common microstructural constituents found in plain carbon steel are ferrite and pearlites. These structures are too small to be seen with the naked eye. Therefore, we used an optical microscope after preparing and etching the specimen. Understanding these microstructures helps engineers determine the strength, hardness, ductility, machinability, and overall quality of steel. Now we are going to explain ferrite. Ferrite is a solid solution of carbon in alpha iron. It has a body center cubic or BCC crystal structures. Ferrite contains only a very few small amount of carbon, approximately 0.02% at room temperature. Because of its low carbon content, ferrite is soft, ductile and easy to machine. Under an optical microscope, ferrite appears as bright or white region after proper etching with nitals. Ferrite grains are generally polygonal in shape with smooth grain boundaries. Key properties of ferrites include soft, highly ductile, good toughness, magnetic at room temperature, low hardness, and excellent formability. Pearlite is not a single phase, it is a mixture of ferrite and cementite arranged in alternating layers called lamellae. Pearlite forms during slow cooling of austenite at the eutectoid temperature of approximately 727 degrees centigrade. Because cementite is very hard, pearlite is harder and stronger than ferrites. Under an optical microscope, pearlite appears darker than ferrite. At low magnification, pearlite looks like dark colonies. At higher magnification, the fine lamellar structure becomes visible. Properties of pearlite include high strength than ferrite, higher hardness, better wear resistance, and lower ductility than ferrite. Formation of ferrite and pearlite when steel cool from the austenitic region, different microstructures forms depending on the carbon content and cooling rates. In low carbon steel, ferrite begins to form first because the carbon content is low. As cooling continues, the remaining austenite transform into pearlite. Therefore, the final microstructure usually contains bright ferrite grains surrounded by darker pearlite colonies. The amount of pearlite increase as the carbon content increase. Now we are going to explain how to sample preparation. Before observing the microstructure, the specimen must be prepared carefully. The steps are: cut the specimen, mount it if required, grind using progressively finer abrasive paper, polish until a mirror-like surface is obtained, etch the surface using 2% to 5% niter, wash and dry the specimen. Observe it under the optical microscope. Without proper polishing and etching, ferrite and pearlite cannot be identified clearly. Now let us discuss how to identify ferrite and pearlite. Ferrite appears bright or white because it is less affected by the etching solutions. Pearlite appears gray or dark because its lamellar ferrite cementite structure reacts differently during etching. At 100x magnification, ferrite appears as bright regions, while pearlite appear as dark patches. At 500x magnification, the lamellar structure of pearlite becomes much more visible. A simple rule to remember is bright region indicate ferrite and dark colony indicate pearlite. Always examine several fields of few before making your conclusion because the microstructure may not be uniform throughout the specimen. Thank you for watching.